Someone might have warned you about recursive lookup with static routes, but nobody ever actually explains what recursive lookup is. So you're left recursively looking for an explanation. Let's fix that today. I'll show you exactly what recursive lookup means and what it looks like when you configure it on a packet tracer lab. Hi, I'm Colleen from Mom Teaches Tech. You look like you're ready to learn today, and that makes me really happy. Let's get started. First, what is recursive lookup? When you configure a static route using a next hop IP address, the router doesn't immediately know how to reach the destination network. First, the router has to figure out how to reach the next hop. That extra step to find the exit interface is called a recursive lookup. This is not a failure condition or a problem. It's normal router behavior. All right. Here's our packet tracer network that we're going to use. We have a 192.168.0.0/24 network on the left. We have a 192.168.3.0/24 network on the right. In between our two routers at the point-to-point connection, we have a 10.0.0.0 network with a /30. So we have two usable IP addresses, 10.0.0.1 and 10.0.0.2. If we take a look at our router here to begin with, do a show IP route and take a look at our routing table. And you'll see that to start, we haven't configured any static routes. We only have our two directly connected networks that I talked about, which is the 10.0.0.0 network and the 192.168.0.0 network. Cisco routers support 3 different ways to configure static routes. All 3 work, but they behave differently behind the scenes. The next hop without an exit interface is the only method that requires the router to go through a recursive lookup. We're going to walk through each of the 3 ways to configure static routes. One, using only the next hop that will require the recursive lookup. And then we'll talk about when it makes sense to use each method and sometimes when it can cause issues. When you use next hop only, the router has to recursively look up how to reach that next hop. Using next hop only is especially common on Ethernet links because it clearly identifies which router the traffic should go to. This avoids the router treating the destination networks as if they were directly connected. We're going to start out on the left-hand side router, enable IP route, and we need to go to the 192.168.3.0 network. 255.255.255.0 is our subnet mask for that network. And our next hop is 10.0.0.2. If we exit and show IP route, we should see our route to 192.168.3.0. If you configure your route with only a next hop IP address in the command, the router has to figure out how to reach that next hop first before it forwards the packet. That process of figuring out how to reach the next hop is recursive lookup. When you configure a static route using only an exit interface, the router doesn't need to do a recursive lookup. It just sends the traffic out the interface that you specify. This works well on point-to-point links, but on Ethernet networks, this can cause unnecessary ARP traffic because the router may treat the destination as directly reachable on that link, when in actuality, there's a router or routers in between. This can also cause packet forwarding to fail. So it doesn't mean that it's wrong in all situations, but you would not want to use this on an Ethernet link, Let's take a look at how we configure static routing with just the exit interface on a point-to-point serial interface link. We'll configure R2. I don't believe I've put any commands in at all for R2. I haven't. Let's go ahead and give us a host name. Host name. We're going to be R2. Now I need to do IP route, and we need to go to the 192.168.0.0 network, which is 255.255.255.0 subnet mask. And this time we are using the exit interface. It's just exit interface 000, and we should get a little warning here. And we do. We get a warning, and it says basically, if this isn't a point-to-point interface, then don't do this. Okay, now we're to our third and final method of configuring a static route. This method also does not require recursive lookup. We can specify both the next hop and the exit interface. This gives the router the most precise forwarding information. This avoids recursive lookup, and it also may avoid ARP issues on Ethernet. On a true point-to-point link, which is what we're using in Packet Tracer, the router views using the next hop plus the interface and using the exit interface only result in the same forwarding behavior. So let's take a look at this configuration type with next hop and exit interface in Packet Tracer. Remember here on R1, we configured this router. Let's take a look at how we configured it. You can just see it in the show run. Your running config shouldn't be that bad in any of the CCNA classes, and you can just do a show run. Here's our route. We configured it with the next hop. This requires a recursive lookup. We give it the IP address that it needs to hop to, which is 10.0.0.2, but we don't give it the exit interface. So now we can do both. First of all, go into global config mode, and then we have to remove our route. We're going to do no IP route. And just type in what you did before. We were going to the 192.168.3.0 255.255.255.0 network with the next hop of 10.0.0.2. We're taking that route out. We can verify that a couple of ways. You can look in your routing table here. We've taken it out. It's not there. We're going to tell this router, router 1, to use exit interface serial 000, and we're going to give it the next hop. We do IP route. We tell it the network we want to go to, which is 192.168.3.0. 255.255.255.0. We're the same up to here. Now we tell it the exit interface. We're going to use serial 000, but now we also tell router 1 the next hop. And our next hop is 10.0.0.2. There we go. There's our full command. This does not require a recursive lookup. Okay, our routing should be working again. Let's make sure it's in the routing table. So do show IP route. We have our static route going to 192.168.3.0. It has an administrative distance of 1 via 10.0.0.2 out of serial 000. Okay, great. Test our configuration by a ping, of course. We're going to ping 192.168.3.0, enter, ping successful, yay! Always exciting when your ping is successful. You should do a little celebration when you have a successful ping. Okay, now that we went through that, you might think, oh, I'm always going to use next hop and exit interface. But that isn't necessarily always the best option. There are other environments that are generally beyond the scope of the CCNA, where you would not want to use next hop plus exit interface. For example, there might be times when the IP address on the other side of the link would be likely to change. Then it would be a bad idea to use that next hop IP address. So you would only use exit interface. What you need to remember for the CCNA is that recursive lookup is required when you configure static routes with just the next hop. You know, static routing isn't always the right tool in every situation. And thank goodness for that, because it requires a lot of work configuring every router with proper static routes. Later, you'll learn dynamic routing and move on from static routing, but you need to have a good grasp of static routing. Well, it's the basis of routing. For Cisco networking and CCNA exams, remember that when you use a next hop only, the router will do a recursive lookup to find the exit interface. So I hope this made sense for you. If it did, well, then we're winning. Have a great week.